Hello and welcome to Session 3, Get Data in Power BI. I'm Andrew Conniff, a Microsoft technical trainer specializing in data and AI. Let's jump right in. In this section, we will discuss how to identify and connect to various data sources. Selecting the right data source is crucial for the accuracy and reliability of our reports. We will look at the different types of data sources, including databases, web services, and files. It's not uncommon to work with data in several databases and file locations. These data repositories are different from each other and are in Microsoft SQL Server, some are in Microsoft Excel, CSV files, but all the data is related. And when connecting to the data, the default behavior is that the data is imported into our Power BI desktop file or PBIX file. You aren't directly affecting the underlying data with Power BI. And we can also connect to a variety of sources with a live connection in a read-only mode as well. Power BI offers over 190 connections with a wide variety of data sources. These are some of the most common, but not inclusive of all. Certain connectors have different initial configurations, but they all connect to the data and allow you to turn it into meaningful insights. First, we see the Get Data dialog box with file grouping selected. Notice the CSV and Excel files here, as well as folders. Next, we have our database top connectors. We have our Power Platform connectors like Dataverse. And then we have Azure top connectors like Azure SQL Server. And then we have other online services that we can connect to. The different types of storage modes we can choose from are the import mode, which allows us to create a local copy of our data from our data source into our semantic model. And we can also import semantic models, and imported semantic models support all transformations, unlike DirectQuery, which is another consideration, when we choose which model to use. So import supports scheduled semantic model refresh and is the best choice for reports that can tolerate 30 minutes or more before a refresh. This is the preferred method and supports all transformations. DirectQuery creates a direct connection to the data source, and that ensures that our data is not cached and we're always viewing the most up-to-date data. This is dependent on the data sources, typically only available for relational databases, and the performance of the report and the database are directly correlated. So we want to be sure to communicate with our database administrators before using DirectQuery to ensure that it is going to be supported. Dual and composite is a way that's going to identify some data to be directly imported and other data that must be queried. And finally, we have direct link, which is similar to DirectQuery for Microsoft Fabric data sources. When you use the DirectQuery method, the overall user experience depends heavily on the performance of the underlying data source. Slow query response times will lead to a negative user experience, and the worst case scenario, our queries might time out. The number of users who are opening the reports at any one time will impact the load that is placed on that data source. For example, if your report has 20 visits or 20 visuals and 10 people visiting it, and they're using it at the same time, we have 200 or more queries that could exist on the data source simultaneously. And that's with each visual issuing one or more queries. Unfortunately, the performance of your Power BI model will not only be impacted by the performance of the underlying data source, but also other uncontrollable factors such as network latency. Faster networks will return data quicker. And the data server, the performance of the data source's server and how many other workloads are on that server. For example, consider implications of a server refresh taking place while hundreds of people are using the same server for other reasons. Therefore, using DirectQuery poses a risk to the quality of your model's performance. To optimize performance in this situation, you need to have control over or access to the source database. It is best practice to import data into Power BI Desktop, but your organization might need to use the DirectQuery connectivity mode. If your organization needs to use DirectQuery, you should clearly understand its behavior within Power BI Desktop and be aware of its limitations. You will then be in a good position to optimize the DirectQuery model as much as possible. When you use DirectQuery to connect to data in Power BI Desktop, that connection behaves in the following way. DirectQuery connects directly to data. Only the schema is imported. Visuals only fetch data from the source when built. DirectQuery's near real-time performance relies on underlying resources and caching, and refresh visuals will see the underlying data updates. It requires a data gateway for on-premises data sources, and dashboards have scheduled auto refresh and can be manually refreshed. Profiling data is about studying the nuances of that data, determining anomalies, examining and developing the underlying data structures, and querying data statistics such as row counts, value distributions, minimum and maximum values, averages, and so on. This concept is important because it allows you to shape and organize the data so that interacting with that data and identifying the distributions of the data is uncomplicated, therefore helping us to make our tasks of working with the data on the front end and develop report elements nearly effortless. Before you begin examining the data in Power Query Editor, you should first learn about the underlying data structures the data is organized in. Profiling data occurs either prior to or in parallel to the data shaping. So understanding which tables are related is important so we can configure the relationships in the data modeling step. After we have created a connection to a data source and have selected transform data to get to the Power Query Editor, then we can determine if anomalies exist within our data. Data anomalies are outliers typically within our data. So column distribution shows the distribution of the data within the column. A column profile gives you more details about the data in that column, including basic statistics. The value distribution graph tells you the counts for the unique value in that specific column. And the column statistics will also include how many zeros and null values exist, along with the average value in the column and the standard deviation of the values in the column, and how many even and odd values are in the column. Cardinality is a term that is used to describe the uniqueness of values in a column. But cardinality is also used in the context of the relationships between two tables and describes the direction of the relationship. When using Power Query Editor to analyze the metadata, the column distribution options on the View tab displays statistics on how many distinct and unique items are in each column in that data. The distinct values count is the total number of different values that are found in that column, and the unique values count is the total number of values that only appear once. A column that has a lot of repeated values in its range, distinct count being high, will have a low level of cardinality. Conversely, a column with a lot of unique values, like an ID column, is going to have a high cardinality. Lower cardinality leads to more optimized performance, so you might need to reduce the number of high cardinality columns in your semantic model. Power BI Desktop offers different techniques that you can use to help reduce the data that's loaded into the data model, such as summarization. And reducing the data that is loaded into your model will improve the relationship cardinality of the report. For this reason, it is important that you strive to minimize the data that will be loaded into our models. This case is especially true for large models or models that you anticipate to grow and become large over time. Perhaps the most effective technique to reduce model size is to use a summary table from the data source. Where a detailed table might contain every transaction, a summary table will contain one record per day, per week, or per month. It may be an average of all of the transactions per day, for instance. While importing data into Power BI, you may encounter errors resulting from factors such as Power BI imports from numerous data sources, and each of those sources might have dozens or sometimes hundreds of different error messages. Other components can cause errors such as hard drives, networks, software services, and operating systems. Data can often not comply with specific schemas. And some of these specific errors could include query timeout. This is where hardware resources are being constrained by concurrent users using the same data. Timeout expired indicates that we have pulled too much data according to our organization's policies. Couldn't find the data. Power BI expects the data formatted as one type and it comes in as a different type. Could not find file, caused by the file either moving locations or the permissions on that file changing. Data type errors, an error in interpreting the data types in Power BI. The resolution to this error is unique to the data source. This isn't an exhaustive list, but shows common errors you may encounter. Now let's go to a demonstration and see how this works in Power BI.
Here we are in Power BI in our data sales analysis, our starter file, and we are going to take a quick tour and then we're going to connect it to our data. As we notice the top area here, we have a ribbon, and on this ribbon, we're going to see several items. A lot of these first items on the Home tab are Get Data shortcuts. I can also enter data and connect right here. So that's our data window right there. The next area is our queries. So when we open up the query editor, we go to Queries, Transform Data. This is what opens up our Power Query editor. And then we have our Insert New Visual and Text and whatnot. Here we have Power BI Desktop open. We have our sales analysis file open, and we don't have any data connected yet. We open up this tab, we can see there's nothing connected. And we're going to go ahead and connect to our data. Quick tour of the product, we can see that we have a report view for the canvas. We have a table view of our data, which there is no unconnected, and model view also for data. And then we have the Copilot view, where when we connect to Copilot, we get logged in. We can use Copilot to help us write our DAX queries. As you notice, the ribbon at the top changes depending on what view we are in. And so our tabs at the top will also change. The home view on the report page is the starting point. We can do quite a bit from here. And the transform data window is where we would be able to work with our data once we are connected. We can see there's no data connected. And this is the Power Query editor. And you may see that referenced in the future, and that is how you get there. We do have quite a few connectors that we can use. We will be staying with information on this. I'm on a virtual machine on the virtual machine, but we can connect to Azure. We have other online sources, and much of the connections are very similar. There's a endpoint that we put in, and then some sort of authentication that we will have to do to retrieve data from those sources. So we're going to close this, and we're going to use one of the shortcuts that are up in the data center section here. So we're primarily going to be concerned with data connection and then our queries. So let's connect to a SQL server that's on this machine, and that is at localhost. Select OK. We have a Windows default authentication, and up comes our database. Go ahead and open up AdventureWorks 2020. And we see we have quite a few tables. Now we don't have to import the whole database. We're going to bring in just the parts that we want. Employee value here. We're going to add the product, the reseller. There we go. And we're going to want employee sales territory and sales territory. There we go. And we want the fact reseller sales. There we go. All right. Now we're going to transform the data. Now this is a shortcut. If I just load this window will disappear, and then we'll have to navigate to the Power Query editor. But when I say transform data, it just takes me straight to the transform data window. So let's explore. And if we go to the employee table, we can view quite a bit about it. We can get the example. The first 1,000 roles are sampled for us. We can also go to the view here, and we can see our column quality. And here we can see that we have 100% valid. Here we have an empty value, and 100% on the other ones. We have another empty value here. And as we peruse through our data, we're going to make decisions based on that. We can scroll side to side to see everything that's inside of here. And as you can imagine, we probably don't want all of these columns. We can bring up the column profiles, and as we select the columns, this will change. We can see we have, again, one empty shows here. We have distinct and unique. Distinct being there is more than one of these in here, but they are distinct. So there's 48 of them. And there's one or more of them in there. And there's 4 that are unique though. So there's 4 that only appear one time, and we can check some other values. And if we do column distribution, then we can see this up in the top area as we scroll through. So we may want to go, if we don't want to read the whole profile, we can look at the distribution as we're going through and make decisions based on the results that we're seeing here. Now, if we look at some of the others, we have products, and you see that our settings follow along with us. And we can look at dim reseller. As we go through the columns, as they're selected, we get more information. We have our column profile on. All right. And if we go through here and look at some of these values, we can see business type. We've got our added reseller, and it looks like we have 2 values here. So when we are going through and we're looking at our value distribution, column statistics, we can find things out like this. We have 2 spellings of warehouse. One is 2 separate words and one as a single one. So we can look through some of the other values. Here you can see we have some values that probably will need to be broken out. When we get to transforming the data, we will come in and choose which data we want to keep, expand it out, and then eliminate some of the other values so that our semantic model is smaller. We can just go through and check each of these and preview them here. And then here's our fact table. Fact table, not as wide of a table. There is plenty of values here. We also have links to several other pieces of data. All right. So what we want to do now is get some additional data. We have some data in a CSV file, and I'm going to show another way to find the data. Every connection to a data source is a query. I can say new query, and I can find my file. So I can do Excel workbook, or I can do CSV. What I'm looking for is a CSV file, and I want to bring in my reseller sales targets. We'll open that as a new query. We'll select OK. And here we see we've got the same options for the tabular data that's showing here. And we have one more to bring in. So we'll new query, CSV, and we'll bring in the color formats. So when we work with this data, here we have the color formats. There's not quite a bit here, but it has some information that we can combine with our data about our products. It's going to help us format a good business story and tell the tale of our business intelligence. Right? It's a good example of bringing in our data, and we save and apply our changes. And now when we open up our data, you can see we have all of the information showing on the data. And that brings us to the end of this demonstration.
This concludes our session. There are many ways to continue your learning journey, and we encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.